Hello, so in today's class we will look at what is called the code of conduct. So in the last classes we have seen from a given point you can draw from a given point which is not lying on the conic, you can draw a pair of tangents. So we have seen how to obtain the equation of these tangents. Now the pair of tangents will touch a conic at 2 points. അപ്പോൾ ആ പോയിന്റ്സിനെയാണ് നമ്മൾ point of contact എന്ന് പറയുന്നത്. So if I am taking a point x1, y1 which is not lying on the conic, and you can find points x2, y2 and x3, y3 which are points of contact of these tangents with the conic. By chord of contact you mean that is the line which is joining these points of contact. അപ്പോൾ നമുക്ക് രണ്ട് പോയിന്റ് ഓഫ് കോണ്ടാക്ട് കിട്ടും, അതിനെ ജോയിൻ ചെയ്യുന്ന ലൈനിനെയാണ് നമ്മൾ chord of contact എന്ന് പറയുന്നത്. Okay, so that's the definition of chord of contact. So it is a chord joining points of contact of tangents to a conic from a given point not lying on the conic. So you have a point which is not lying on the conic, so from there you will have a pair of tangents. So the chord joining the points of contact is called chord of contact. So let us now look at what will be the equation of the chord of contact. So consider the conic. So let us take the general equation ax square plus 2hxy plus by square plus 2gx plus 2fy plus c equal to 0, and let x1 y1 be a point from which tangents are drawn to the conic. And let us take x2, y2 and x3, y3 to be the point of contact. So let the point of contact be x2, y2 and x3, y3. Now at x2, y2 and x3, y3 the conic will have tangents, and we know what will be the equation of the tangents. So the equation of tangents at x2, y2 and x3, y3 are so that will be a, so you will get x2 plus h x y2 plus x2y plus b y by 2 varum plus g x plus x2 f y plus y2 plus c equal to 0, and at x3, y3 you will have ax x3 plus h x y3 plus x3y plus b y by 3 plus g x plus x3 plus f y plus y3 plus c equal to 0 respectively. So these are the equation of tangents at the point x2 y2 and x1 y1 x3 y3 respectively. These tangents, so these two equations will pass through the point x1 y1 also. കാരണം ആ പോയിന്റിൽ നിന്നാണ് നമ്മൾ രണ്ട് ടാൻജൻസ് വരയ്ക്കുന്നത്. So since these lines, so since these tangents pass through x1 y1, we get, so therefore those equations will be satisfied at the point x1 y1 also. So we will get a x1 x2 plus h x1 y2 plus x2 y1 plus b y1 y2 plus g x1 plus x2 plus f y1 plus y2 plus c equal to 0 വരും. അതുപോലെ a x1 x3 plus h x1 y3 plus x3 y1 plus b y1 y3 plus g x1 plus x3 plus f y1 plus y3 plus c will be equal to 0. Now from these two equations, അപ്പോൾ നമുക്ക് ഇതിനെ മറ്റൊരു point of view ൽ നോക്കാൻ പറ്റും. Okay, so this is like an equation which is passing through the point x1 y1 and it also contains the point x2 y2 and x3 y3. അപ്പോൾ നമുക്ക് ഒറിജിനൽ ഇക്വേഷനെ x1 ഉം y1 ഉം വരുന്നത്, അതായത് ax x1 plus h x y1 plus x1 y1 x1 y plus b y y1 plus g x plus x1 plus f y plus y1 plus c equal to 0. So if you are taking this line, അപ്പോൾ ഈ line എടുത്തു കഴിഞ്ഞാൽ, since these two conditions hold, we can say that x2 y2 and x3 y3 lies on this particular line. So we can suggest that this will be the equation of the required line. കാരണം ഈ ലൈന് ഈ രണ്ട് കണ്ടീഷൻസും സാറ്റിസ്ഫൈ ചെയ്യുന്നുണ്ട്. So this will be the equation of your chord of contact. Okay. So the above two conditions suggest that line ax x1 plus h xy1 plus x1y plus b y y1 plus g x plus x1 plus f y plus y1 plus c equal to 0 passes through x2 y2 and x3 y3. Hence the equation of chord of contact of tangents, hence this is equation of chord of contact of tangents through x1 y1. അപ്പം ഈ ലൈൻ വരുന്നതിൻ്റെ റീസൺ അതാണ്. So we know that if you are given any 2 points in the two-dimensional space, there will be a unique line which is passing through the 2 points. അപ്പോൾ 2 പോയിന്റ് തന്നു കഴിഞ്ഞാൽ അതിനെ join ചെയ്യുന്ന പോലെ നമുക്ക് ഒരു ലൈൻ സെഗ്മെന്റ് ഫോം ചെയ്യാൻ പറ്റുള്ളൂ. So this will be our required equation. As you can see here, this equation is identical to the equation tangent at the point x1, y1. But here the difference is നമ്മൾ ടാൻജന്റ് ഇക്വേഷൻ എടുക്കുമ്പോൾ ടാൻജന്റ് a point x1, y1 എന്ന് പറയുന്നത് it lies on the conic, but here you have a point x1, y1 which is not lying on the conic. Okay, so the equation of chord of contact is identical with the equation of the tangent at x1, y1 on the conic, but here x1, y1 does not lie on the conic. Look at an example for finding the chord of contact. So here you are given the conic and you are given the point x1, y1. So the equation of chord of contact is A x1 plus h xy1 plus x1y plus p y1 plus g x plus x1 plus f y plus y1 plus c equal to 0. So that implies, so here A is 2, x into x1 is 2 plus h is 2h on. So let us write the value. So A is 2, h is 3, b is 4, and g is minus 4, f is 0, and c is 7. So h is 3 into 3x plus 2y plus b വരുമ്പോൾ 4 വരും. 4 into 3y plus g is minus 4, x plus 2 വരും, f is 0, c is 7. So simplifying, this is what you are going to get. So we will get 9x plus 18y minus 1 equal to 0. That's the required equation. Problem is you have the point minus 1, 2 with respect to the conic 7x square minus 8xy plus 5y square minus 4x minus 6y plus 5 equal to 0. So here we have a equal to 7, h is minus 4, b is 5, g is minus 2, f is minus 3 and c is equal to 5, and the point x1, y1 is minus 1, 2. Now the equation of chord of contact will be given by 7 into minus x minus 4 into 2x minus y varum plus 5 into 2y and minus 2 into x minus 1 minus 3 into y plus 2 plus 5 equal to 0. So upon simplifying, we will get the equation of chord of contact to be minus 17x plus 11y plus 1 equal to 0. So this is how we obtain chord of contact to a given conic with respect to the point x1,